If you've been a follower of my channel for a long time, you heard me say in the past that each week I have many companies offering to send me products to show on my channel. I decline 98% of those requests. electronicsNmore was not created to be a product review channel like many others on YouTube. Many channels on YouTube use YouTube for the sole purpose of generating huge sales on Amazon. I am not one of them. I have hundreds of videos with no product links. And for the first few years after my channel was created, I helped countless people and got absolutely nothing in return. My videos were not even monetized. If I do show a product in my newer videos, it must be of good value, be well made, and have high buyer satisfaction ratings. Some products you see on my channel I bought myself, some I requested that Banggood sent to me, and very few of the products shown on my channel were offered to me by companies and accepted. The two items you see here, the Jackery Solarsaga 60-watt panel, as well as the 200-watt portable power station, those were offered to me and I did accept the offer. Of course, when I do this review, you are going to get an honest review on both of these, and you're going to see very thorough testing for the power supply unit as well as the solar panel. I spend a lot of time making videos and helping people, and many times I'll end up making no money in the process due to a lack of exposure for my videos. When you do see product links on my channel, the purpose is to get a very small commission to help compensate me for videos that were unprofitable. As everyone knows, you cannot work for free. I don't force anyone to buy products using my links, but I sure do appreciate viewers that use provided links. And in case my viewers are wondering, 95% of my income comes from ad revenue, not product sales, like many other people on YouTube. Okay, let's get started with the review. Now I'm going to take a look at the portable power station first. The second half of the video, you'll see all the testing for the Solarsaga 60 panel. Okay, here's a closer look at the portable power station. Now, Jackery is a Honda licensed product, and that's what caught my attention when they contacted me, and I said, how bad could it be? I went on Amazon and other websites, read the reviews, and they were all very good. This model is called the Explorer 240. It has a 240 watt-hour storage, and the maximum output for the 120 volt receptacle, which is a sine wave output, which we're going to check, is up to 200 watts. Now, something this size is ideal for a person that wants to go camping for a weekend. They don't want to spend a lot of money on a much larger power station. You're just looking to power some 120 volt light bulbs, charge up your laptop, tablet, and other devices. And this can also come in very handy for people that metal detect, because you can charge up your metal detectors while you're out hunting. This unit can be charged using the AC mains adapter. It's a switch mode power supply, which I'll show you momentarily. You can also charge it from your vehicle or using a solar panel. Let's take a look at the specifications. And right over here is the battery. Lithium ion, 16.8 amp hour, 14.4 volt nominal voltage, and basically 242 watt hours. Inside this unit you have 4 lithium ion batteries. They're connected in series, and then you have a few groups of those batteries in series connected in parallel to increase the current capacity. Here's your weight, 3 kilograms, 6.61 pounds, and there's the dimensions. This unit has 2 USB ports rated 2.4 amps each. You have a car port, 12 volts, 10 amps, or 120 watts max, and the AC output is 110, and it's 1.82 amps at 60 hertz. Continuous rating for 200 watts, and if you're using a motor appliance to handle the surge, it goes up to 400 watts. Charging input is only around 3.5 amps of current at 12 volts, supports 12 to 30 volts. We're going to check all this out to make sure these specs are right. And it has certifications, and it has a 2-year warranty. And like everything else, made in China. Now, the one thing that I noticed about companies in the US that sell Chinese-made products versus companies in China that sell made-in-China products is that the US companies generally give you good specifications. They don't over-exaggerate the specifications, and the packaging, how everything is explained, is very clear. The ones made in China by Chinese companies, usually the instruction manuals are very poorly written. So let's open this up and take a look at the inside. Okay. And right over here it says important, charge the unit to full capacity before using. And it says for maximum battery power, charge now and every 3 months, or keep it plugged in when not in use. Store in a dry, cool place. And then you have the support information at Jackery.com, phone number again, and the website. Little card. And the instruction manual, we'll take a look at this in a minute. So here's one bag, put that down. Okay, you can see how nice and compact the unit is, and it's actually not that heavy. 110 volt receptacle, you have your 2 USB ports, input for charging, and your display. And you have your 12 volt accessory socket. You turn on each one by pushing the buttons you see here. Let me charge the unit up fully before we do any tests on this unit, but let me show you the back of it first. That's one end. And this end over here has a cooling fan. On the bottom of the unit, you have these very nice, which looks like neoprene pads. They do not come off easy. It's not like it's gonna peel off, I don't think. Nope. Very strong. Switch mode power supply for the wall to charge using AC mains. Plugs right in. And if you want to charge it using your vehicle, you could do the same thing. Just plug this in and put that in your accessory socket. Now the good thing that I see already is that this one can be charged directly from your car battery. Many of these portable power units, the voltage is too low from your car and it will not charge the unit. So that tells me that there's a voltage boosting circuit in here, or a step-up converter to take the lower voltage to be able to charge the 4 lithium-ion batteries that are in series. Okay, and here's a look at the manual. Take a look at this side first. And just looking over it to see how well it was written, here the LCD screen will flicker 10 times when battery capacity drains to 20% and 10%. Okay, so when we see that later, we'll know. Don't use higher than 40 degrees Celsius or less than 0. Let's see everything else here. And here's some stuff that you can power up and how many times you can recharge or how long you could use it for. And let's take a look at the back side here now. Everything appears to be written well, unlike many other instruction manuals that I've seen in the past. Not waterproof. And that is it. And there's your warranty. Let's take this off. I'm going to fully charge this up, and when I come back, we're going to measure the voltage of this receptacle. We're going to be putting a load on this receptacle, just a little under 120 watts, to make sure it's able to handle it. We're going to take a look at the AC output on my oscilloscope. I want to make sure the sine wave coming out of here is very similar to the sine wave on the AC mains in my house. We're going to compare the two. We're going to see if this can handle up to 200 watts. We're going to test just a little under 200. We're also going to test the USB. We're going to put a load on those to make sure they can handle it. And I also want to take a closer look at the input to see what kind of power we can put into this unit to get it to charge as fast as possible. Okay, let me charge it up. Okay, this is the charger that's included. Let me plug it in. We'll see what kind of current flows into the unit, what kind of wattage. 38 watts, and we're at 79%. So when we're done doing the test for the AC receptacle, we'll come back, we'll plug this in when it's down around 15 or 20%, and we'll see if more current flows in using this cable. If it doesn't, we're going to do some experiments. Let me allow this to charge, and we'll be back. And you can see 99%, that's as high as it goes. If you're wondering, this is a 12 volt 5 amp charger. If you do not use any of these power outputs, this will automatically turn off. Okay, let's power this on. Let's turn on the 12 volt receptacle. See the green light? We're going to measure the voltage. Go all the way into the center. 13.3. Alright. Later on I'm going to check the voltage of that receptacle when this is drained way down. We're going to compare it to the 13.3 when it's fully charged. Some of these portable power supplies have an issue that when this drains all the way down to like 15 or 20%, you only end up with like 9.8 to 10 volts at this accessory socket. And usually when you start dropping below around 10.5 volts, you're going to have a problem powering some devices. So I want to check that to make sure it stays high enough in voltage. Let's switch over to AC now. Let's turn on the receptacle here. And it should be right around 110. Let's see. Fine. We're going to look at that on the scope and compare it to the AC mains in a minute. Let me take a look at the power on the USB. I'm going to be using this load tester right here. It may be a little difficult to see the display. If it is, I'll read it to you. So I'm going to plug this in. First, let's turn it on. Turn that off. Oh, one thing I want to show you. I just noticed. When you turn on the receptacle, you can see there's a little bit of standby current. It says 4 watts, goes down to 2, then back to 5, then to 4. Now it's at 3. That's to power this circuitry for the sine wave inverter. So we're going to have to add that to the output later. So I'm going to probably use a load on this receptacle that's going to be around 195 watts. Let me turn this off. Let's put the USB on. Going to connect up this load tester. Okay, we can take a look at the output voltage. That's 0 power right now. 5 volt output. And that's set for 3 amps. So let me turn this way. Let's put it down to 2.39. Keep it just a hair under. Okay, now I'm going to power it up. I'm going to leave that connected for about 20 minutes to make sure the USB port can handle it. But let's take a look at the display on the power station. And it says right over here we're drawing 12 watts from that port. And that's very close to what the electronic load says. Okay, it's been 20 minutes, no problems. You can see we're at 97% now. This was working just fine. Let's take a look here. 11.9 watts, 5 volts. Okay, let me pop this out. Now I'm going to repeat the test with the top one. Power's on, active. And you should see this come all the way up in a minute. There it goes. Let me let this sit for 20 minutes, come back, and we'll make sure that this port can also handle the load. Okay, 20 minutes has passed. We're still at 12 watts, and you can see we dropped to 96%. So this entire USB port works just fine. Now let's take a look at the accessory socket. Okay, for this test I'm going to be putting a load on the accessory socket. I'm going to keep it under the 120 watt rating. I'm going to let it run for about 20 minutes to see how well this handles it. Let me turn this on. And we're at 96%. Let's put this on. And you can see the output voltage over there at 13.3. And I'm going to turn this on now. It's a little noisy. Okay, it's down to 80%. I maintained a load of around 114 if you average it. So that's just a little under the 120 max, and I ran it for just over 20 minutes, and there is no problem at all. It's just slightly warm. So this accessory socket can definitely handle the current. Pull that out. Okay, now what I want to do is we're going to take a look at the sine wave coming off of this. We're going to compare it to the AC line. Okay, you're looking at the sine wave waveform off of my AC line in my house. Peak to peak is 344 volts. So from the zero line, which is the middle, it goes positive 170, and from the middle line, which is 0, to negative is 170. So from top to bottom gives you the 340. Of course, when we measure voltage, it's an average, so it comes out to right around 120 volts. Now I'm going to connect up the portable power supply, and we're going to take a look at the waveform to compare. Okay, we're all connected up on the portable power unit. Let's take a closer look at the screen. And as you can see, it's identical to the one for my AC mains. 344, you can see it's touching that bottom line, touching the top line, so it does have a sine wave output. Alright, now before I test this receptacle to see how well it can handle a load that's going to be just under 200 watts, I'm going to use a resistive load. I first want to take a look at the surge capacity of this receptacle. In order to do that, I'm going to be using this palm sander. It's rated at 2 amps. It's a motor, so when it starts up, it's going to draw more power than 200 watts. Now I want to also check to see the accuracy of this display with the reading you see right here for the wattage. This one here I know works very well. I tested it with my meter. So let's plug this in. And you can see 0 watts. And we'll compare it to over here. You might be able to see how high it spikes when I first power up the palm sander. And here we go. So keep an eye on this one and that one. And as you saw, this jumped well over 200 when I started up the palm sander, but there is an unusual thing going on here. This is drawing a little bit more power because, like I said earlier, to power the inverter circuit, so this number is going to be a little higher. But I noticed once in a while, when this was showing 127, this was actually showing like 10 watts less. So I'm not too sure of the accuracy of this meter when it comes to measuring AC power. So this does have the ability to handle surges, which is good. Now we're going to take a look at how long we can operate a load just under 200 watts using a full charge. So first let me charge this all the way back up, and then we'll be back. And you can see 99%. Now what I'm going to do is I'm going to put a resistive load. It's going to be this 150 watt halogen lamp and that 75 watt incandescent bulb. I'm going to plug it into the receptacle, and it's going to start right around 200, and then it's going to drop just a little below 200 watts, and that should be fine for this test. I'm going to time how long it runs with that load, and hopefully it does not turn off. I'm going to plug in my other meter so I can compare my meter reading to the reading inside the unit. And there we go. And you can see 191, 194, 195. It's going to fluctuate. See, it goes a little above, which is weird because this is still below. I don't know why it does that, but it does that with the AC. DC, it doesn't do that. 204. So as long as we're right around that 200, we're going to watch this now. Okay, it's about 15 minutes. And everything is working fine. You can hear the cooling fan is running right around 193 watts. This one here is not exactly the most stable or accurate. I'm going by that one. It goes over and under. And you can see we're down to 73%. But that's pretty good because we're almost to the maximum of 200. And it's been going now about 16 minutes. Okay, 37 minutes has passed. We're still 192 to 195, and we're down to 47%. It's been running continuously and has not turned off. Over here, 16%, and we're at 57 minutes, so almost an hour with the 200 watt load, or just a hair under 200. Cooling fan is quiet, and it never turned off. So what I'm going to do now is turn this off because there's 15% remaining. I want to do some tests on the USB and accessory socket just to see if there's still enough power. Okay, let's check the voltage of the accessory socket with this drain down to 15%. 13.3, excellent. So this could be used all the way down to a low level. Now let's take a look at the USB output. That's on. Make sure that's still good. And you can see it's back to the 11 watts. Right over here, 11.9, 5 volts. So that's working good. Okay, so this definitely works as advertised, up to 200, no problem. These work, no problem, the USB. The accessory socket can handle a high load, and it works all the way down to a low voltage. It does not drop in voltage when this drains all the way down, which is good. The only issue I saw was the fluctuation in the wattage while using the AC receptacle. Okay, now let's take a look at the input power. Alright, let's see. Before it was 38 watts when it was around 80 something percent. Let's see if it's higher when it's lower. So it's 38 watts regardless of the state of charge. When it nears full charge, this does taper off. It goes 38, 30, 20, 25, and it just drops all the way down. Now the only issue I have with this whole system so far, I'd like to see more current going into this unit for charging. This way it charges faster. 38 watts is a little low. That's why it takes about 8 hours from fully depleted to charge back up. Let me disconnect this and hook up my power supply. Okay, we're at 36 watts with my power supply set at 12 volts and 3.5 amps. Now let me increase the voltage of the power supply, and we can keep an eye on the input wattage. Now we're at 13, 14, 15, 16 volts is right there, 49 watts. Let's go to 18, 56 watts. Let's go to 19, 59. Let's go to 20, 63 watts. So that's very similar to what the solar panel should be putting out when we test it. Let's go higher. 22 puts us at 69 watts. 23, 73 watts. 24, 76. 25 at 78. And let's go to 26. And it's 78 still. Nothing's happening. Let's try 27. Wow, now it's going backwards. So it looks like 26 volts. Let's go to 25. Yep. If I go to 26, let's see. 26 is like the limit. If you go above 26, let me try 26.5. That's okay. 26.8 volts. This drops straight back down. So if you want to charge this at the maximum, you would have to have 25 volt supply rated at 3.5 amps. Right now it's 25 volts at 3.09 amps. So the only issue I have with this unit is that the charger that goes into the AC mains should have been a 25 volt output at 3 amps. This way you can charge this up much more quickly. Besides that, everything else works just fine. Okay, now let's go on to the solar panel. Okay, you're looking at Jackery's Solarsaga 60 watt output, 18 volts. Has a very nice carry handle, very comfortable. This piece right here lifts up. The panel can be propped up at an angle. Nice canvas material. Let's take a look at the back. You have an extension cable. Plugs in very easily, just line up the two. USB-A and USB-C. USB-C is 3 amps, USB-A is 2.4 amps. In a little while, we'll be testing these outputs. Right here's the model. Peak power 60, cell efficiency 23%, power voltage 18, 3.3 amps, 21.6 open circuit voltage, 3.63 short circuit current. We will check all of this to make sure that this panel lives up to these specifications. Okay, this is what it looks like when the panel's folded open. You have 3 semi-rigid panels. The surface is rain resistant, but it's not intended to be waterproof. So if you're going to have a heavy rain, you do not want to leave this outdoors. You can see there's a grommet on each corner to make securing the panel very easy. Let me wait for the sun to get a little brighter. There's a cloud right now. We're going to measure the light intensity hitting the panel, and then we're going to check open circuit voltage as well as short circuit current, and then plug it into the unit to see if it does indeed put out 60 watts. Okay, the clouds moved out of the way, and it's a pretty clear day, very little haze. You can see we're around almost 81,000 lux. Let's take a look at the open circuit voltage. Panel's been out in the sun for a while, 24 volts. And let's take a look at the short circuit current now. Push it to here. Right around 3.42 amps. Now what I'd like to do is take a look at the power output using the electronic load. Okay, we're right around 80,800 lux. Let's plug it in and take a look right over here where it says input, 64 watts. So this panel is definitely putting out. The reason why it says 4 because there's a little bit of power being used by that receptacle that was on. 64 watts from the panel. So this panel definitely meets or exceeds the 60 watt rating. Now I'm going to go behind the solar panel and we're going to check the output for the USB ports. Okay, the load tester is set for just under at 2.39. You can see the voltage from the panel right now is at 5.1 with no load on it. And now with the load turned on, you can see it's 10.7 watts and right around 4.5 volts output. I did leave this connected for about a half an hour in full sun, and there was no issues at all. It never turned off. Okay, we're now testing the USB-C port on the back of the panel. This is the voltage right now, open circuit, 5.1. I have it set for 2.98 amps, which is just a little under the 3 amp rating. Right now the solar intensity is around 81,000 lux. I'll turn it on. Might be hard to see, but it's 2.98. 13.4 watts. That says P for power. 4.5 volts. It's actually a little higher, 4.55. I checked it. And that's it, 2.98. And I did allow this to sit for about 20 minutes. No problem at all. It maintains exactly what you see right here. And that is it. I hope you enjoyed this video. If you did, be sure to rate thumbs up, share, and check out my extensive video playlist for many other videos of interest to you. Thank you very much for watching.